Hello Apes, and welcome to the fifth in our screencast series for Chapter 1. And we're going to take a look now at manipulative experiments and natural experiments. And we're going to see that when we do manipulative experiments, that we're going to get what they consider the strongest data that is available, because what you can do is you can control more of the variables that can influence your results. You can control what you're testing. You can reveal causal relationships that might exist within what you're testing as well. And it's going to give you, I don't want to say more accurate data, but more data to work with. Not all data has to be accurate, and when I say that, what I mean by that is there can be mistakes that are gathered that help lead you to other conclusions or other problems that lead you in the right direction. You know, we joke about the invention of the light bulb. How many times was the light bulb how many different ways was the light bulb tried to be made? I think it was over 1,000 before one actually worked. And each mistake, that we learned something from that mistake, and we were able to develop the light bulb from it. So that's manipulative, that you're actually going to be working with the variables, controlling the variables, and seeing what relationships exist and gathering that data from that. In natural experiments, we're going to get evidence, but it's going to be a little bit harder to collect that evidence because we're dealing with the real world. We're dealing with the natural environment, and we have very little control over those variables. So it would be like, if you had me, you watched Jane Goodall among the wild chimpanzees, and Jane couldn't control the behavior of the chimps, although she did try to lure them into camp so that she could see how they would behave. But she had to learn by observing and following and checking out what they ate and how they interacted and learning about the plants in the area, and it came with a lot of patience. So in natural experiments, we use the existing conditions to test and make predictions, and we don't have control over those variables. Going back to Jane Goodall, she made sure that she stayed in the same color clothes and she sat on the same peak, and those were the things she was able to control. The results aren't always going to come out with specific numbers or specific characteristics. So as it says on the PowerPoint, it's not going to be neat and clean, nor are the answers going to be black and white. They're not going to be obvious. You're going to have to test over and over and over again, or observe, I should say, not necessarily test, but observe over and over and over again until you can start formulating patterns and being able to make those predictions and conclusions from there. One of the things that we did not really talk about, but we mentioned back in your sophomore year, was something known as a peer review. And one of the things that happens is that there are safeguards and checks against faulty research. And one of those checks is something called a peer review. And the scientist or environmentalist will publish their work so that other scientists, other environmentalists can review their work and see and replicate the work. We know that if it cannot be replicated, if you're not going to be coming up with the same results, then it's not going to be valid. So they're going to put this through a peer review. Other people that might have an interest are going to take a look at this, and they're going to check the validity of the work. So I mentioned publishing it in scientific journals, and then using their ideas to compete for funding to continue their research. And when you have to compete for funding, you're going to make sure that you dot your I's and you cross your T's, and you're going to make sure that you're following the work specifically. One of the things too, and I know that you've learned this throughout your educational careers, is when you're looking up for research, when you're looking up anything for research, you've got to make sure that you're using a valid source. And that's what we're talking about here in a peer review. Is that scientist valid? Is that work valid? Is it swayed in any way? Is somebody like supporting them, giving them financial support, and they have to lean more towards what that organization or group wants them to find? So those are some of the things that you need to be considered about the sources. Okay, so here's a flowchart that shows the scientific process. We've already talked about the scientific method. So now once you get your results, you're going to produce a scientific paper. That paper is going to go through a peer review. It has one of two ways to go. It could either be rejected, where you're going to have to start all over again, or it's going to be accepted. And if it's accepted, that's when you can publish it into a journal, and then it can be further researched by the scientific community. So this is not going to work, so you're not going to be able to click on this, and we're just going to go on. We've tried this last year and it just didn't happen. And nor did this. Okay, so have you ever heard of a paradigm shift? Ooh, sorry. Have you ever heard of a paradigm shift? So a paradigm shift is a dramatic upheaval in thought. It changes the dominant viewpoint. So back in, I want to say, the late 1990s, Al Gore came out with a movie called An Inconvenient Truth. And it talked about global warming. And of course, people that did not like Al Gore, they really mocked and tried to find every fault that they could with the work that was done. And just recently, we have another actor. There's another famous person who I want to say it's Leonardo DiCaprio, but I may be wrong. But just as cute, the guy who did this. And he did a similar program and similar research called Before the Flood. We're going to probably watch that this year in class, or you'll probably watch it at home for an assignment. But it took what Al Gore presented in Global Warming and An Inconvenient Truth, and it elaborated on this, and it showed current findings, and we know this now as global climate change. And pretty much 100% of the science, we'll say 99.9% of the science, is valid science, and it says that our climate is changing globally. Not so much warming as we thought. There are some areas that are warming and some areas that are cooling and some areas that are droughts and some areas that are getting a lot of rain. But it's a dramatic upheaval in the way that we understand this. So a couple of things. We've talked about theory in the past, and a theory, as you know, is a well-tested hypothesis that is held true test after test after test. It consolidates widely supported and related hypotheses. We know that, we have the cell theory, and that's still a theory because we figured there's still things we haven't discovered, so maybe not all things are made up of cells. But everything that we have is supported by the cell theory. So these are theories that are well tested, and they're a widely accepted explanation. So when we talk about global climate change, that's in a theory stage. We know that the Earth goes through environmental changes, so we consider that global climate change is happening as part of this natural process, but also we're considering that there's 7 billion people on the planet, and humans alter the face of the planet more than any other species does. So we could have some impact and speed up this process, this natural evolutionary process. So that's where a theory comes in. There are what is called, and you probably never heard of this, wicked problems. And these are problems that are complex with no simple solution. And wicked problems are grouped into environmental problems. They're the problems that we're facing today, and we're having such changes in natural cycles that they present a much more difficult way to solve them. And that's what a wicked problem is going to be. You've heard me use the term sustainability over and over again, and this is the idea that we must live within our planet's means so that the Earth and its resources can sustain us and all life for the future. Sustainability is going to involve conserving our resources. You did your ecological footprint. How much of the Earth's resources are you actually using? And is there any way that you can cap that use and still live the type of lifestyle that you want to live? We need to develop long-term solutions, and throughout the year we're going to talk about different solutions. We're going to see, I think, both sides of the coin pretty easily about where we are, what we're doing, and what solutions are out there, and we're going to kind of take a hard look at U.S. policies and see how U.S. policies have really been slow in getting going, and that we need to speed this up, and we need to keep our ecosystems functioning. That's so important. Okay, one of the things that you're going to hear is that we're going to talk about the natural capital. And this is the Earth's total wealth of resources. So those ecosystem services that I mentioned before, that $33 trillion value, well, we're going to think about those sources and our use of those sources as kind of a withdrawal. And what we are realistically doing is we are withdrawing those resources faster than they can be replenished, faster than we're putting money back into the bank. So we must live off the Earth's natural interests, and that's anything that is replenishable, renewable resources, not its natural capital. So those are some of the things that we will be looking at and trying to see different ways of being able to do that and still maintain the same quality of life. One of the things that you've heard me talk about already is population, and we're going to consider population size, and we're going to consider its consumption drive, how much we are consuming those resources. Our population is growing exponentially. Now it's slowed a little bit, but it's still, because one of the things that we know is if you're in an industrialized country, it's much more expensive to have children, so people are not having as many children and they're waiting till they're older in life. So we're seeing a slow, but the growth rate is still growing exponentially, adding about 200,000 people a day to the planet. And that puts more consumption on those resources, and that consumption has risen faster than the population has. Life has become more pleasant for the majority. If you go back and you even think of the time of, you know what, I'm sorry, I got distracted here. We're running out of time. I can only do this for 15 minutes. So let me stop here, and we'll come back and we'll talk about the Great Depression and that in the next presentation. All right, see you in a little bit.